My name is Sachin S. Gunthe, and I am the coordinator of the recently established Center for Atmospheric and Climate Sciences here at IIT Madras. What we do in this center, we try to do the routine measurements as a part of our field measurement campaign to understand the role of the changing aerosol properties in the cloud and precipitation formation. These aerosols are nothing but the tiny suspended particles in the atmosphere, which has a large implication for the climate because they directly interact with the incoming solar radiation and are important for the cloud formation. What happens is that since we really don't understand the exact role of the aerosol in the cloud formation, the aerosol cloud interaction represents the largest uncertainty in the current and future understanding of the climate change. So prior to the COVID, we were planning to do our routine long-term measurements, and then obviously the lockdown badly hit us. So while doing so, I talked with one of my students and requested her to shut down all the instruments and then go home. But she persisted and said that maybe it is a rare opportunity and we would get a good science out of it. And indeed that happened. So what essentially happens is that the aerosols, they have majorly three sources, that the traffic, industry and the power plant. Now during the lockdown, since the two sources related with the industry and the traffic were at its lowest, we could essentially understood what the exact impact of the power plant emitted aerosol on the cloud and precipitation formation is. Now since we were able to delineate this difference, now it is probably will help the climate modelers to develop the better parameterization, which will probably help in reducing the climate uncertainty related with the aerosol and cloud interaction.
My name is Aishwarya Singh, and my doctoral work involves studying the long-term properties of atmospheric aerosols. So the present study, which was conducted during the challenging time of COVID-19 lockdown, brings about the clear impact of power plant emissions on cloud and precipitation forming processes. What we found is that the gaseous emissions, especially the sulfur dioxide from power plant, can give rise to certain aerosols which have very high cloud forming potential as they are rich in sulphate. This study particularly would not have been possible under business as usual condition, because at that time we have aerosols coming from other anthropogenic sources as well, and hence it becomes difficult to delineate the effect of certain specific sources. Hence I believe that this was a very good opportunity to study such properties.